record. Everything that goes is recorded. And then you shoot it wherever you want to shoot it. I do this for my students. All my lectures are recorded. When I'm done, put them on my YouTube channel. And unfortunately, not all of them take advantage of it. You know how students are. They just want to get through. Okay, so this is basically the first title sheet. That's the project. Symbols, because in the electrical industry, you guys are master. If you're a master, you're an engineer. In the state of Minnesota, you can lay out and plan, right? You might think this is a job of an engineer. This is not a job of an engineer. This is a job of you if you're a master. Masters in the state of Minnesota are allowed to lay out and plan. What we're doing here, we're laying out and planning. And you can sign off on a bunch of buildings. There's certain buildings you have to have a registered engineer to sign off on it. Other buildings you do as a master have this power. So these are, I always say, because in the electrical industry, we don't express ourselves good, or we don't have enough words to describe what we do, so we invented symbols. That's how I describe the symbols for our students. You just have to write an encyclopedia to describe a 4,000 amp 48277 switch gear, so we show a symbol for that one. So these are the symbols. You guys are familiar with them if you're in the industry. Next, we have what we call it the one-line diagram riser. You're going to see two forms of it. We bring the power from Excel to this 4,000 amp switch gear for 8277, and then we have a generator backup right here that backs up the emergency panel here. You'll probably, if you guys design a system, you're familiar with emergency panels right here through an auto transfer switch. Then we also back up most of the switch gear here. Supposed to be two generators. This guy only put one generator, that's for the record. And then we have a bunch of panels, guys. Here's my two receptacle panels at 28120, and we have cooling towers and a couple of mechanical equipment connected directly here, and we have some mechanical equipment also connected to this. And these are our bus duct. We have a big bus duct coming out of the 4,000 amp switch gear to feed the manufacturing floor. We have two of them. One is 288 and the other one is 480. And you know why we choose the 288, 480, to get them into the transformer. So that's our riser, and I don't want to make it. Here's we have an MCC here that we feed all our mechanical support equipment, your heating, cooling, ventilation, tons of equipment, exhaust fans have to be fed, so we have to feed these from an MCC. And these are the bus duct that we have, and we feed. This is a 288, this one is a 480. Disconnect SO cord with a plug and tie to the equipment. Typical commercial industrial design. So feel free, guys, to stop me at any time if you have any, and they have to size this system. They have to size the bus duct, they have to size the sections of the bus duct, and so forth. So then we have, of course, the riser for the voice and the fire alarm system and security interface between all these systems, plus the input-output devices that we do. And this is your parking lot. We're familiar with all the parking lot. You're looking at trenching from the sign all the way to all these lights back. It should go to the building here. And we have a security light right around the building, as you can see here. So they have to be sized, specified. They have to pick the type of the light they use and size it, disconnect it, power it, and disconnect it, of course. And then we have, this is a snapshot at the building inside. What you're looking at, the blue ones are the lights that we're using. Metal halide in the manufacturing area. This year we moved completely, this is a couple of years ago. This year we moved completely to LEDs. Everything is LEDs. This project that we're using right now, we design everything LEDs. Okay, so here's the second floor, the same thing. All the lights are circuited. They have to be circuited, tagged if you're familiar with the design, circuited, switched, and tagged, identified from a power circuit.
Just a quick question.
Yeah.
Now, when you did that change to LEDs, what's the percentage of change to your total power consumption in the building?
Brent, we are using 277 lighting system, and if you guys use 277 lighting system, you can literally put 100 fixtures, LEDs, on a 20 amp 277 light. Obviously, you'll be a fool to do that design-wise, right? Really, on one circuit breaker to trip half of the fixtures in your building. So really, the volt amp and the amp, when you have LEDs, becomes irrelevant. You know, being an engineer, always when you design based on the code and volt amp, and then based on those poor electricians who are going to maintain the system for the coming 50 years. So an isolate, disconnect, isolate, and work on these equipment. So I typically tell the students, don't put on a 277 20 amp, don't put more than 30 lighting fixture, no matter what. And even less, 20 to 30, because again, the amp is not an issue. It becomes the, you know, being able to control the circuit to work on them. And of course, you don't want to put all your eggs in one basket, you know. So that's kind of, so really with LEDs is not an issue. Here's a power system, guys. These are all the bus duct coming from the switch gear right here. And by the way, this switch gear should not be against the wall. This is done by students. So if you criticize it, there's something that um, that was not right. If you're familiar with the switch gear, you need front and back access to them. And we have a bus duct, two bus ducts coming here. I don't know if you see two colors and feeding all these equipments with their disconnects and tags for all the equipment. We have some mechanical equipment here tagged and some receptacles, plus the computer rooms right here is also powered. And I'm going to move fast through them, guys. We have a mold. These are benches at the top. So we have a mold, and we're feeding that mold, power mold, from the top to feed the benches because they're working on this lab. And we have some support areas here. And please stop me at any time. Then we do the low voltage, guys. We have a tray, a cable tray, and these are in 3Ds. A cable tray that goes through the whole building, collect all this data together. And I have to move because I want to finish in half an hour. Otherwise, I wouldn't be able to. Same thing, low voltage second. We also do lightning protection at the top of the building. Plus, we have some mechanical equipment. We have a rooftop units. I don't know if you can see these. We have a cooling tower here that we need to disconnect and power. So we show the disconnect and the power for the cooling tower. If you're familiar with that one, I'm sure you are. And a couple of exhaust fans, plus a lightning protection complete for the whole building. And that's and when we invite for all these guys, we invite lightning, Thompson Lightning. So there's an expert comes and for every topic that we do. So really, they get sick of me because I have them 1 year. My wife even gets sick of me most of the time, but that's a whole different story. So really nice to have to break that continuity and have multiple experts come and fit their knowledge into it. You're familiar with the panel schedules, code requirements, so they have to identify all the circuit that's going everywhere in their building. We have equipment, fixture, and mechanical schedule have to be identified, or the lighting fixtures and mechanical. This is just a snapshot at the data center that we have here. You're familiar with servers, so you come racks, and we're feeding all these computers. We used to feed them 120, now we're feeding 208. So every one of these squares is actually a rack of computers, 8 foot, full of servers, and we're plugging in multiple output. If you guys you work on Target, so they're plugging in to give them redundancy in the power with the UPS and PDUs. If you're familiar with these terminology that they use in data centers, so that will expose them to a data center design system. Just a couple of things about the riser I'm going to go through. So this is presented by the students, by the way. I did not put this together. Just to give you an idea. At the end of every project, we invite the industry. If you would like to be in our mailing list, let me know. And we do the presentation right here. So we get usually 15 to 20 electrical engineering firms and or electrical contractors, the major ones in the metro area. And they witness that same presentation done by students. And guess what? They hire the students that they're coming to hire. So right now we have 10 students in the program. 8 of them are working at Parson and Hunt and Egan, and a bunch of other contractors. 8, and they're going to graduate in May 17, mind you. And they have been working for at least 6 months as an internship after the classes. So it's really good. There's a need in the industry for this. So moving on, here's the switch gear. You guys are familiar with the drought switch gear power circuit breakers. I'm sure a lot of you guys have designed system like this, back access. So they have to go online and find cut sheets about the equipment they install. You know, they don't give it to we don't give them to the customers, but you have to prove that you know what a bus duct is. So hopefully that was approved. An MCC, we use all our mechanical equipment. We have an MCC motor control center, so they have to have the drives. We have VFDs, and we have across the line contactors, magnetic starters, and so forth. So that's a quick one here. Any quick question, guys, about this? Yes, sir.
When you went to the LED lighting, what did that do to the initial cost of the project?
You know what? We haven't done the estimating yet.
Okay.
But I can tell you from talking to Davis and Associates, anybody deal with Davis and Associates, they are our rep when it comes to, when we do lighting, we also do tour lighting reps, and we bring their experts. It probably will increase 30 to 40% your cost. That's what I heard so whatever we used to be our cost will light-wise. Light-wise. Yeah, because everything else stays the same.
Right.
Yeah, lighting-wise, probably 30 to 40. Anybody has? You guys are contractors. Anybody? Yeah, 30 to 40% increase in the price. But for us, we care less. We're not paying for that. Right? Remember, we're designing it. So you guys are going to be worried about that. So let me just fly you right through another residential. I know some of you probably do residential. Here's our residential project. I'm going to fly right through it. Here's a quad building, quadruplex, duplex. We have the symbols, the same thing. We have a swimming pool, believe it or not, for the apartment. I mean, that's a really high-end apartment with garages. So we have structures, multiple. The idea is to get them into powering multiple structures and meeting the code disconnect for different structures. So we go into code intensive, you know, with especially with Chad here. We get into the to powering a swimming pool. So we get into all the details and about the swimming pool and so forth. And then here's our swimming pool. We're putting light inside, wet niche luminaires in here, a couple of receptacles here, a couple of mechanical equipment. We have a cover to cover the swimming pool and a heater. So we go fancy on these our swimming pools. And these are our garages. And I don't know if this is. I like this to be my garage, but if I'm designing somebody to code, I know I'm way above and beyond the code. As you guys know, in a dwelling garage, all what you need is one GFCI receptacle. So we remember, cost is not an issue, and we tell them that. I have a friend of mine, engineer, always say, if you meet the NEC Code book, if you just met, basically you did not violate the law. You did not break the law. So being engineers, we always go at least 20 to 30% higher when the code says and everything. I don't know if you guys are designing system like this. This happened to be the two apartments, and we have the power, all receptacle. We do the spaghetti here, showing them how to put crank circuit, and we go intensive in code requirements for the kitchen countertop receptacles and the GFCI and Arcflash circuit interrupters and all these residential intensive code that you have to do. Unlike commercial, where a whole lot of things in commercial, you can do anything you want. So that's another thing. We have an upper level too. So we have lower level and we have an upper level that we have to do power. Same thing, upper level, low voltage. So we have a security system right around the building. We have smoke detector, power smoke detector, not low voltage smoke detectors. Phone and data. So we go for that one. Same thing, lower level. We have a lower level power here. So what we did here, we have all the furnaces, mechanical equipment are here, boilers and so forth. So we end up with disconnects. So you have to have a disconnect within sight of the equipment. So get into all the disconnect location for equipment. Really cool, that room, and teach them a lot about the code. Then we do lights. So we don't go fancy on the light. We don't do lighting calculation and schedules. And we have, for this project, we're using, and again, some of you are familiar with this. This is wrong, right? Anybody recognize that this is wrong? Usually you don't disconnect the mirror ahead, done by students. So I'm not trying to, so there's issues here, if you're familiar with that one. Mechanical equipment, here's the meter, multi-meter socket that we used. 6 of them, we have 4 apartments, and some of them use 6, some of them use 4, so that will bring the meter in, and you have your 6 disconnect rules, and you go to each one of these apartments. That's the system that we did. We have only 4, so, and we have a house panel, like most of you guys have done residential, you have to have a house panel. Okay, so that's the second project.
Was that the students' logo in the upper right of the drawing?
Yes.
Okay,
Yes.
Gonna have fun making
They take ownership of it. Let me show you what one of them did to me and my partner Gary Ryman at one time. This is one of their projects, the commercial project. So they really some of them take it really serious, and when they go to a job interview, we told them, you have to take this with you. What did you do at Dunwoody? Here's my project. What better than saying I designed a 4,000 amp switchgear and I can show you. You're an employer. What don't you think? At least, trust me, I wouldn't trust their design of 4,000 amp switchgear, but I would trust you to check their work, though. So what we say is trainable. So they take really pride of their work. So, and you can see some of their stuff that they do here, because bottom line, they take this for a job interview. Their job depends on us. They can't carry tools, remember, they can't say we can wire a light, so they have to have something. So so that's one. I'm going to show you just a quick lighting calculation. Here's a software, and again, any question, guys, we can, for lighting calculation, here's a software. Everything that we do is a software. We're all softwares. We don't do things by hand. So lighting calculation, for example, this happened to be the commercial the industrial project done by student today. All the lights that you have seen, these are the LED, by the way. These are LED lights. So every one of these is a light. And the calculation that you're going to see, all these are calculation. If I can run my calculation here, and it will tell you the foot candle based on the criteria that we give them. We give them criteria, of course. What's the foot candle average that we want you to meet there? And they run the calculation like I did here, and it will tell you. You can see that right now is 78.4 foot candle. we have statistics, and I really don't want to make do too much of it. If you pull the statistics here, it will tell you the area that you are in. And here's generator electrical room. The average is 29.5. I think we asked for 30, if I remember right. So very close. So they have to prove, not only just put a fixture and color a day, they have to prove that they meet the criteria that we give. And that criteria is given by Michelle Cooley Erickson engineering firm. They have to meet the criteria for the type of the equipment. Okay, so that's, I thought, just to show you some of the lighting calculation, how the lighting calculation is done in the software. We get all these free. You guys can get them at any time. So that's our lighting calculation, and I don't want to overwhelm you with that one. I thought to show you too, generator sizing. For generator sizing, we have a software that's called Cummins. Everybody's familiar with Cummins, Anand, old Anand? They give us their software to size generator for the building. So our students, if you're familiar with sizing generators are sized based on running load and starting load. So the more you split them in segments, the more you can, the smaller your generator will be. So here's the steps that we do. We have step 1, step 2, step 3, step 4. So we chunk the loads as we throw them on the generator. If you're familiar with sizing, and that's a major thing. That's a major thing. And then we put our lighting panel. That's a commercial project. Receptacle panel, air handling unit, cooling unit, and cooling unit heater, I believe this one, and the AC. So all these loads are thrown, and long story short, then you get in here, and it will give you the size of your generator. Let me see if I can size it here. Run size. Okay, here you go. Run my size. And again, first you have to model your load. Put all the kVA, the horsepower, the starting mechanism across the line, VFD. And then you get into a size of a generator. We're using 150 kW generator at 28120 system here. So that's when they come up with a generator, they have to do this type of calculation, if that makes sense. So there's a lot of intensive lighting calculation, and I'm looking at the clock here, trying to meet the deadline, self-imposed deadline on myself. So we got that one. So generator sizing, we got your generator. I'm going to leave the analysis, guys, to the end here. So, okay, so we got that one, generator sizing. I want to do, these are all softwares that we have. I think we have, I have Minnesota, the energy code. Now, where did they put it, Chad? So many things are open here. Okay, so let me just go open. What is this? The commercial industry. All these software, guys, you can get them at any time. Here's our energy code software that we use. When you throw your fixture, it's not enough to throw your fixture. You have to meet the energy code. So what we use is we use this software, and that software is sponsored by U.S. Department of Energy. And then you can pick, you're familiar, guys, with the energy. You can pick any, here's Minnesota, the location, but you can pick really any code you want based on that location. I believe Minnesota is ASHRAE 90.1 2004. That's what we adhere to right now. But I made the students run it at 90.1 2010, which means every area have to have multiple levels of switching. You have to have occupancy sensor, lighting control system. So we're getting to all this stuff to go above and beyond what the code is. So anyway, so that's another. We do also interior and exterior. So your parking lot and your security light outside the facade around the building have to meet the energy code inside, outside. And I give him a report, really unique. Anybody have done any of these? Do you guys do any? I thought I opened one. I apologize for this. Here's a commercial project that's done by the students. Just to give you an, okay, we'll get this one here quick. See what those guys did. I hope they did something. Okay, so you can pick the fixture that you want. Did we open interior lighting? No, we did not. I don't know. Okay, here you go. No, we don't want this one. Okay, so let's me file, open again. Save changes. No, don't save changes. Okay, open it. All right, so I don't have one open. Okay, maybe I'm not waiting enough here. Going too fast on that. So anyway, so they get to run a report, and it will tell you at the end that it meets the energy code or it doesn't meet the energy code. Green means good and red means bad. So that's kind of, and do you have an envelope? This is not just for us, this is also for the mechanical. The mechanical, we use the envelope. You're familiar with the architect, mechanical use the mechanical, use mechanical, the architects use the envelope. So this is one way of meeting the energy code. Okay, so that's basically what I want to show you. Let me see if I can get you. This is also done by students. This is just explaining the lighting they did. So when we invite the industry, every student has one aspect of the project to do. Those guys did lighting, inside and outside. So look, this is all done by students using the software. Here's the criteria for lighting that they have to meet based on specification in every area. This one we have to use recessed light, fluorescent lights down, compact fluorescent lights down, and so we have, that's a criteria given by the engineering firms that we deal with. Because I don't know about you guys, if you tell me an order comes to you and what type of light do you want here, well, you have to have some type of a start point. So we give them a start point, you know, for a lot of stuff. Then they do the calculation. Here's all the calculation that they do. And they do a lot of, we do it by hand also. We have a lighting class that we do the zonal cavity calculation. So all this that you're looking at is done by students and then circuited and controlled. This one has a control panel that they have multiple relays, that they have 2 and 3 pole relays that they have to interface it with occupancy sensor, motion detectors, and so forth. So, and of course, the luminary schedule, because so we need to go by the luminaires. And here's a couple of cut shots about, these are not fluorescent, these are direct and indirect light that they use. And so that's done basically by a student about lighting. Typically, it's 10-minute presentation. 2 students will do it in front of the industry, what you're looking at. Only 10 minutes. No more than 10 minutes. People's time is so expensive, right? We can't sit them here for 4 or 5 hours. So we come for typically 2 hours, everything is done. Okay, so that's, before I move into, I know we said we'll talk about Arcflash. Now we're speaking a language you're probably familiar with, right? Arcflash, Arcflash, you guys are familiar with 70E. To meet 70E, here's one book for you. You can meet this one with 70E. I don't know how many of you guys have seen this one. We teach it when we do 70E training. Handbook for Electrical Safety. Anybody have, if you don't have this book, make sure you have it. I don't know if they have an older version of it. Really, really cool about Arcflash. This is, of course, this is must have if you're an electrical contractor or an electrician who teach safety. Must have. My other favorite tool is SPD, Selecting Protective Devices, guys. With what we do right now, because of the NEC Code 2011 change, you have to have the available short circuit at the main, right? So this will walk you through how to do calculation by hand or use, they have a little calculator that you can do here. So these, everything here, you really don't need, if you're like Chad, can get a $50,000 software for free. They love us because we train them. Everybody knows how the industry works, right? They train them on their software, and guess which software they're going to buy when they go or recommend. So they give us this literally 50 grand software for free. We get it. We train our students, called SKM Power Tools for Windows. It does short circuit calculation, over current protection coordination, arc flash analysis, and it gives you the most important thing for you as contractors and interested in that little label that says arc flash hazard. And based on 70E 2012, this one now you have to put more than just arc flash hazard. You have to put the calories and the PPE or the boundaries, the arc flash boundaries. All this will be given to you, either you do it here or hire an engineer or somebody else to do it for you. So I'm going to show it how our students do it. Mishad will do it this way. Yes, sir.
So I bring up, and that has become a huge thing in the electrical industry. We got into this about a year ago. We've done a couple projects, and over the last month, I've gotten 3 calls from different facilities. Insurance companies starting to require that they will have it done.
So our students come to you as contractor ready to hit the ground running with the software if you have it. And if you don't have it, they at least understand how to use the software when you have it. Okay, so that's, any comments, guys, before I move to a completely different software? This is what I showed you. These are designed. One thing I didn't show you is how Revit works, right? I don't think I showed you Revit, and excuse I have so many softwares that I get confused. Here's the model of Revit. This is the commercial building that you guys, I'm an engineer if you're laughing, so all what we do is softwares, right? So here's a model of the building 3D. So we took the building that we used to do to CAD 4 years ago. We built it, and I don't take credit for it. Our architectural helped us, and also one of my very bright students actually put it together. Very, very bright. And he was generous enough to share it with us, and we jumped into Revit 5 years ago, training people how to do Revit, because our industry wants us to train Revit, and we serve the industry, right? So that's kind of your building. the 3D model of your building. You can render this. You can make walkthroughs. I have a walkthrough, but I forgot where I put it. I apologize. Otherwise, you can walk through really, it's unreal. But we don't do walkthrough. Typically, the architects do. But what they require us, at least the engineering firms right now, is to do your project to Revit, give it to the architects, then they will do rendering and walkthroughs for the owners, and they get the job. You know, I'm sure, I don't know if you guys use any of the.
Just starting to come in.
Yeah, for major project, we talked to Michelle Cooley, which is the largest engineering firm here. They said for there's certain projects we cannot get them unless we have Revit. Okay, so our students have this kind of tool plus CAD. We have CAD, of course, the old way of CAD. But let me just show you. Revit is an interesting animal. All the stuff that I showed you guys is right in here. So you saw the 3D here. That's brand new. You do this, the student I have this year designing this project, and they are not done with it yet. So this is how it's going to look like with their logos and all this stuff. So they get into designing the tile block and putting all the sheets and making it look nice. Then we get into the power. Now we're start to use a riser. Here's the riser. You saw there are two ways of doing the power. There's the one-line diagram and the riser, if you're familiar with that one. So the contractor love risers. So here you go. You're looking at a riser. And these are generators. Those guys did it right. We have two generators bringing the power into 4,000 amp switch gear. And of course, the utility transformer going to a CT cabinet. As we all know, you have to have a termination box CT cabinet with a meter. And then from here, you take this power and you distribute the power directly through the whole building. We have receptacle panel, lighting panel, mechanical panel 1, emergency panel, UPS, and we have two PDUs. I don't know why they're not showing. They should show these two PDUs. And then we have a bus duct 1 and bus duct 2. We're just showing it like this in the riser. And we have an auto transfer switch that feed an emergency panel directly from the one of the generators. So that's directly into Revit. If you click on any of these guys, you should come and get some. Here's the section that we do. For example, if you come over here, this piece of equipment, and I don't want to make it Revit. See, it comes as a family transfer switch. From 2,000 to 4,000. Now that's definitely not what we're using. We're using 100. So work in progress. So you can check. We don't use Revit to size equipment. We just use it to put physical thing in one place. Again, if you put an ATS 2,000 when you need 1,000, that's wrong. So remember, done by students. So all this, it looks good. Sometimes the look is deceiving too when you dig deeper into the stuff. So that's one. I'm going to show you the low voltage riser. We just do drafting for the low voltage risers, the fire alarm system, the horns, the strobes, and conductors that we're using for them. That's just a drafting. And then site, you look at the site here, and let me show you if I can get you to get, let me look at the section here, and just show you view, 3D view here. 3D view. Let me see if I can get this one to a 3D view. Here you go. Here's your section. Here's your lighting poles in 3D. So what better than that? If I do rendering or walkthrough, now I can make the owner walk right around the building. And if you dig deeper here, these are all the electrical equipment that you can see here, the bus ducts that they're using. So it's unreal. I mean, it's unreal. The mechanical equipment, you know, so they're all showing in here in the 3D. And so you can, or you can look at them at 2Ds. That's the beauty of Revit, of course. So that's what I wanted to show you. I don't know if I can get this one here. Yes, sir.
Underneath the light poles, were those the footings from light poles, the cement?
Let's go.
Those look kind of strange. I was wondering if it shows all the underground.
Did we do it here? No, not here. I did it on the
3D parking lot.
3D parking lot. So that was site. Let me do back to 3D. Oh, you hear? Yeah. These are the family that comes. The concrete, what do you call it? Pole base for the building. So isn't that cool? I mean, it's just the ability to do that, and you look at them from every dimension that you want that God created for you. So so that's kind of the power of Revit, you know. So that's set this one, and we really right now, because we don't have mechanical guys working with us, we really don't take advantage of Revit collagen detection, meaning your conduit 6-inch rigid is running right through my heating and cooling system. We don't take advantage of it just because we don't have mechanical equipment working directly with us. This is the next thing to do, I guess, when we have things up and running. So that's what I want to show you guys. Here's the bus duct. Let me see if I can get this one to default 3D. No, it didn't do that one. Okay, here. And oops. Okay, the view and 3D and 3D view. Okay, just defaulted to this view there. Okay, so then you can, here's what I want to show you. This is really the cool stuff is this is site. We don't want the site though. We want to go to first floor power, first floor lighting. Here's my first floor lighting. All these fixtures that you're looking at are circuited. This is your circuit. This is your fixture type, and this is your switch that's going to switch. Typical. You know, we don't do spaghetti for these. So these are all circuited, ready to go, again, done. EM is emergency, so we use emergency light. We use exit signs. You can see these exit signs to get the people out of the building. Everything electrical, lighting, power has to be there. And that has been a big challenge for us, guys. It really is. Trying to get things 3D. No longer you just look at 2Ds. And you drop something, and instead of being on the floor, it's in the ceiling when you look at it. And then the students get... It has been a challenge, but it's worth it, though. A lot of people are finding jobs because of this. So it's really worth it. Okay, so that's basically what the project looks like when it comes to Revit. The last thing we did yesterday was lighting. Here's my cooling tower right at the top of the building with my exhaust fans, with a disconnect right next to the exhaust fans. That's how we design it. I know you can if you have an MCC, you can have a disconnect right in the MCC with a lightning protection right here. These are your lightning rods around the building. So if you click on one of these, it should get you. And Revit, if you're familiar with that one, you have to. Or I'm on the wrong location here. So here you have to be in the view to see that one. So here you go. So just that one. All right, come on, Chad. There you go. So that's the family that we're using. It's lightning rod family, and that we're using for this one. And so that's what I thought, guys, to show you a few things. Any comments? Any questions about the Revit? I do, yes.
Chad, how do you handle the computer and the software for the students? Do they lease?
We have laptops. We're a laptop-enabled college. Everybody has to have a laptop. Everything that you're looking at right now, the way, because we do in the design, we do intensive work. So what I do right now is, I told somebody yesterday, here's how I handle it. These are all team folders. They're on the network. I can look at all this work for the students from my basement, VPN, and I'm looking at all their work. I team them up in team of one. Here's team one, for example. This is their fall residential. Here's their commercial. Here's their spring industrial. All their work, everything that they do must be in this folder or they would not move on. So that's how we handle it. No emails. Somebody was talking about emails yesterday. No emails, nothing. How are you going to email this? The project that you're looking at is residing on the network. So two students will be working simultaneously on a central file with Revit. And they can be working from anywhere. They can VPN. The kids can VPN too. It's slow if you're working and your internet is not fast. So it's not recommended, but they can go into their basement and work on it because everything you see is on our network.
Now, are they required to buy the program?
We provide everything. All the softwares, by the way, we only pay for CAD. Every software that you saw, it's free of charge. If any vendor asks you to pay anything for a software, never pay it. I always tell them, do you want me to teach you software? You got to give it to us for free. Every single software that you saw is free except we pay for CAD and Revit, and not a whole lot. So it's really not a whole lot of over cost for those guys. And then we split them, like I said, all their work is going in here. So if you go to the commercial projects, they have the design, the equipment cut sheet. We do estimation. I didn't show estimation, guys. We haven't done the estimation yet. Generator sizing, all their work have to be labeled in these binders.
Just want to clarify on his question. So basically, their VPN, through the VPN, the actual program is on their system.
Yes, you have.
It's not like you need that software in every computer. Yeah, that's remoting in.
Actually, you need Revit in your machine.
Okay.
You do need Revit in your machine but the actual model is residing on the network. So what you do is when you go work, you call Dunwoody, you download the model to your laptop. Work, you're done. You synchronize. There is a function that says synchronize. Synchronize means everything that I did in my laptop shifted to Dunwoody's network. I'm done. When you synchronize, you're done. You can leave. Your partner anywhere else in the world can see your work now when you synchronize. But you still have to have the machine, the software sitting on the machine.
And that may not be the case because currently we're working on our internal systems here, so they may be fast enough that some of them can actually run the software off
From
the server.
hours, yeah.
But that's not a lot.
Yeah, and it might be a licensure issue too. If you have,
You
there's
have to have so
network.
many seats when you just
Yeah, you have what?
have to have so many seats, they'll grab it.
Yeah, and we never had any issues with that one. They have to have a license, check the license. Yes, Mike?
Did you say the students have to furnish their own laptop? Or
No, we buy they lease it from us.
Okay.
They lease the laptops. We give them all the software free of charge, and they pay the lease cost, which costs you an arm and 3 legs. But that's not a different story though.
Now, that's what design and construction electricians, right?
This,
Every student here.
yeah. All the programs have laptop enabled. So for our electrician program, we have PLCs that they must have, and we have a lot of other things that Steve and Karen use with laptops. So I do have to have 5 minutes to show you guys Arcflash. I promise, right? You guys okay with 5 minutes over? You're fine?
Absolutely.
Is everybody? I didn't put anybody to sleep. Okay, I know engineers are boring sometimes, but I left the last one, guys, to the power analysis. If you're familiar with how systems are put together, first we design them, then before we trust our electricians, they go install them and all the stuff. Before we put it in the market for bidding, guys, we run analysis on it. So if you flip the switch, you're not going to burn half of the building. So these analysis, Arcflash analysis, overcaptation coordination that we do much more than that. But typically overcaptation coordination, so if you have a short circuit in this 120 or 277 lighting fixture, do you really want the 1200 amp switchboard done with a trip? And it does. I don't know not here, but it does in other locations. So that's what the overcaptation coordination, big deal, and the Arcflash and the short circuit. So that's what this software can do. Voltage drop, you can do it with this software. So what I did, and this is done by the students, by the way. We get it for free. It's worth, all the modules are for like 40, 50 grand, depending how you put the modules together, for a license or multiple license. So here's our generator, just to walk you through the riser. Engineers, the power system is made out of riser and OneLine diagram. If you don't understand that, that's the backbone of the electrical system, right? So you get your generator here. With cables, you get your utility here with cables coming into both of them. This is an auto transfer switch, service entrance rated auto transfer switch. We're modeling it with 2 circuit breakers coming to the auto transfer switch and feeding the whole building. That's what we decided to do for this building. We're going to put the whole building on auto transfer switch. The money is not an issue, so remember it's a 600 amp system. So. And then we model all the mechanical equipment here and the schedule lighting equipment here, receptacle panel, air handling unit, cooling unit 1 and 2, we put them here. Bigger equipments, 30 horsepower or more, we typically put them separate. Okay, so if you click on, let me just see if we did that one. If you click on this cable right here, this is a model, guys. You can click on this cable. It will give you IEEE 490. These are the cables that you use. We're using THWN. Anybody knows why? We're coming from outside. What location? 600 voltage. We're using a 250, and we're paralleling 2 sets. We're paralleling 2 sets of 250. So you can choose all the wires approved by the code. You can choose how many you need parallel and the length. These are the very important things. Impedance. So that's your equipment here. Then if you get to your generator, here's my KW. I have 225 KW for this project at 208 4-pole, power factor 0.9. So all these are modeled. Everything you put here is not graphed. This is a model. I'm going to take you one more into this air handling unit. Air handling unit, this is happy to be a 15 horsepower, small one, 208, 3-phase, all the information about it. And if you're going to get deeper, it gets into tons and other information. But these are the single most important thing that you need. Then you can get it to the NEMA, and there's a place here. Okay, Chad. Oh, yeah, you can go to the library and pick every single, well, not every single, a lot of equipment, guys, done for air handling unit, for example. It might not mean a lot to us, but it means a lot when it comes to the, I'll show you when it comes to the fuses. Okay, so you build your system, and then the first thing you need to do, you go run and balance short circuit, and you run your short circuit. They give you have 2 warning or fatal error. When my students run it, they usually have 30 to 40 fatal error. A fatal error means you have a conductor with no length, so the impedance is not defined, or a conductor that doesn't have a size. How are you going to have a conductor without a size? Okay, and there's some warning that voltage and so forth. So when you run this, let me just show you quick because of the time here. You go to the reports, and here's all the reports that we can get, but the most important one is short circuit report, and the most important one that you guys care about is right here. So we have the MC, the meter center, the main panel, MP in this case 208. Look at the available short circuit right here. We're having almost 25,000 available short circuit right here as line to 3-phase. The ground fault is smaller as expected. If you go to look at this here, this is the MC that they call it at the auto transfer switch. Look at the available short circuit right here, 34,000. So these are the ones that you put in a label and put it right at these equipment. The same thing goes all the way, and this is very simple system, guys, not complicated. Then, so that's my fault basically, and then I'm going to show you the coordination, which is really the cool stuff. You come over here. Now I'm going to do coordination for the cooling unit number 1. Here's my cooling unit number 1. This is what we call it overcurrent protection coordination. Here's my main circuit breaker, and we are using adjustable circuit breaker. You guys are familiar with this. Here's my long time pickup, long time delay, short time pickup, short time delay, instantaneous. I don't know how many of you guys have done that. Really intensive stuff that they do. And so that's my main, and that's my circuit breaker size for the air handling unit. It's sized at 110 right now, and you can see it allows the air handling unit to start across the line. That curve right here is the start, that 10 second that a motor will take typically 6 times a full load current, right here. And you can see I'm allowing the motor to start. Now, if I move this way, look at the setting. I went to low instantaneous. If I put it and send it to you guys, and you set the adjustment on this circuit breaker to low, your circuit breaker will trip every time you start the air handling unit. Unless you have a VFD, of course. If you have a VFD, it's a whole different story. Okay, so to change this problem, all what you have to do, look at the settings that you have on this circuit breaker. You move it to high. High means your arc flash is going to be high. You might kill one of your apprentices if they go there. So too high is bad, and too low is very bad. So what do you need to do? You need to flip it right in here, very close enough to allow the equipment to start, if you can see here, but not too close to trip up on the start of the equipment. So, and you can do this directly from the setting here that you can see. So all these are the settings that you can adjust on the circuit breaker. Now, who cares? This is what you guys get from the engineers. You get a report like this, and you have to go. So I have, let's just say, cooling unit 1, I think I was at. This is what you get. You get the information, and you have to go and put the info. Here's the thermal curve, instantaneous, sit at high here. And here's the thermal curve, and instantaneous sit at 2. Remember that 2? So they give you this setting as an electrician, and you are supposed to go with the screwdriver and adjust the instantaneous on the circuit breaker. So that's the coordination. The last thing is Arcflash. I know you're looking for the Arcflash. You jump into the Arcflash. That's the new buzz now. And so remember, this is available to every student, free of charge. I mean, it's so you go to the Arcflash, go run. Let's go run. The Arcflash, you come to your, where am I here? Arcflash evaluation. Now, it will tell you, do you want to use 70E? Can you guys see that book right here, 70E? Yep, I want it. Or you can use multiple, you can use ANSI 2012. That's the most common one and defaulted, this book here. So you can run it. Okay, yes, here's my Arcflash analysis. It doesn't seem fancy, right? But you come over here. Now we're talking view. Every single panel that I have in my system will have an Arcflash label in it. And you go continue, and here you go. You're looking at your Arcflash label. Let me show you this one. This happened to be the meter cabinet. Meter cabinets have no overcurrent protection device ahead of them because they are on the line side of the disconnect. So look at this one. You have danger. You cannot work on this MC, the meter cabinet energized. we all know because there's no overconstruction device ahead of it. So that's what, and then you get into flash hazard, 17 feet flash hazard, the flash hazard boundary. And then the calorie 65. We can't go more code-wise more than 40, right, on this one. Dangerous, stay out of that one, don't work on the energized. And then they give you, if you're familiar with 70E, it gives you the shock hazard and the Arcflash hazard. So the top is the Arcflash hazard, the bottom is the shock hazard. You need gloves, 00, and you need limited approach and restricted and prohibited. This is just shock hazard. Not a big deal for a shock hazard. The Arcflash hazard is a big deal. So this is one of them, and let me see if I can get, previous. Okay, so see you, let me go to main panel. Here's my main panel. Here's the main panel. My main panel is acceptable. Look at the Arcflash here. It's 1 foot, flash boundary 1.8. Remember, this is a 2.8 system. 2.8 system is not a whole lot of Arcflash in it. Level 1, Arc rated shirts until you're the level 1, PPE level 1, and all this information. So what we did, I ran this one for our college here. Don't tell us scam here. And we get all these labels, you send them to the printing, our printing department, they printed it to you on a strong piece of label and so forth, and you go put it on all your labels. So that's what I thought, just to give you guys an idea what we're doing. Any questions, any comments? I took 10 minutes more than I'm supposed to. I apologize.
Very
yes, sir.
impressive.
Thank you.
The graduates that graduate and go out, like you say, in electrical design, work for HuntNet, are they getting the experience that allows them to take journeyman and master's tests?
Well, like Scott, my friend, said, we have a 2+1. Now, if they want to be an electrician, which is, I always tell them, to understand our industry, you almost have to be a designer and an electrician, really is. Especially if you want to be a master electrician. A master electrician layout and plan. You are an engineer. So they can come back to us, finish 1 more year. So now they can qualify for the one year credit from the state, and they still have to put their apprenticeship. They put so come back, so they do 3 years with us, then they go to Steve and learn about the bending conduits and the real things of doing things, right, Steve? Doing them the real way. And then after that, they go to the field 3 years, and you get your, depending where you go, 3 years with 1 year credit, 4 years, you qualify for a journeyman.
Okay, so basically, if they go out there as a designer for like Hunt and just stay at that job, they're gonna have a master or somebody else signing off on their work.
Absolutely, or an engineer. Absolutely, yep. They cannot sign off on their work. Unfortunately, we don't graduate engineers. Now we're talking about engineers or masters. Now you have to go to the U of M for this. We're not smart enough. Did you say that? Yes, sir.
The software that does the Arcflash analysis, does that have the capability of allowing for older equipment that you might have to make an assessment of?
Yes, it allows you, absolutely. It allows you to derate based on maintenance, or all the, absolutely. There's a lot of inputs. You either take the default for new equipment, or you can adjust that default to accommodate for lack of maintenance is a big deal for these equipment, and or aging of equipment. Absolutely.
Also, I've been told that if you say, well, I'm just estimating this, I'll estimate this high, that probably can actually create a worse condition if you estimate the fault current too high. It's not going to trip as fast as what you might think it would trip, and you have a longer lasting flash.
Yes. Too good is not good. Too big is not good. Yeah, and when you set your circuit breakers too high, nothing will trip, but also you have a huge, bigger arc flash that can kill some of your apprentices. Yeah, absolutely. It has to be the right way. If you don't have this software, guys, what I always tell the contractor when they do continuing ed, SPD has, you can do this by hand at the end of it. I don't have time to show you. Really, step-by-step calculation by hand. You can do an estimate, have an estimate of the available short circuit based on the impedance of your equipment. So it's really nice one, and you can get it for free online if you go there, PDF file.
The other Cooper-Busman book, that's also a PDF online?
No, I haven't seen this one as a PDF online.
That's one that.
Yeah, unfortunately, but this is great. If you teach, how many of you guys teach 70E? You teach 70E? If you teach 70E, these two, actually these three are must-have for every class that you teach a 70E. Must-have.
Have you got any of the NFPA's seminars on 70E?
No, no. I watched things online, but I've never went into a 70. I don't teach a lot of 70, but I subbed for Mayo Clinic a couple of times for Jeff Kiljick teaches it. So I taught it like 3 or 4 times 70. And that's my introduction to it. I don't teach 70E for my own students other than Arcflash. We go through 70E is a lot involved, as you guys know. There's control circuits and it's really involved. But we teach it at Dunwoody. Jeff Kiljick is our 70E trainer, and I subbed for him many times, Mayo Clinic, and we do a couple of these. So one thing I want to show you, the ones who love the code, and I'm done. I promise I'm done. The Excel sheet. I want you to know where the heck did you come up with all this stuff, Chad? Here's how we size our equipment. We have an Excel sheet, and because we all agree on common denominator between us is called an NEC Code book. So they have to have step-by-step NEC Code book. Where did they come up with the size of these equipment? This is for the commercial building. 180 volt amp for every 180 volt amp for every receptacle in the commercial building. They have to do it. The rating, 10K, leave them alone, higher than 10, cut them by half. You guys are all journeymen and you know how the calculation. So they have to do that intensively, and then they apply a couple of demand factor. I call them CSK for my initials. Diversity factor, and you have to have an engineering factors in it. And then they come at the bottom here with the size of the equipment. They should, if they did it right. So they come, let me see if size of the equipment here. So here's the size of this panel, is 500 amp panel, 100 amp and 225. This is the receptacle, and this is the lighting panel for this project. And then they size the equipment, grounding conductor and the bonding conductor, all the code stuff required. They have to, not enough to do it, but you have to go, where did you get the 500, 240.6? It's not enough just to say, well, I came up with this size. You got to verify it, you know. So that's what I thought, just to show you. All the calculation that we do in the code is based on the NEC Code book. Any comments, guys? Any questions? That's my show. Thank you. Okay, do you guys want to, shall we have 15 minutes break and think my, what's his name? Sam is going to be here in 50 minutes, I think. So let's have 15 minutes break. Is that good? Yeah. Thank you. Mike, okay?
Yeah, we want to make sure that we get to,
So
get everything in here.
we have to get him to go to the bathroom at the end of it. Yeah, thank you.
Yeah, I've used components of this in lecture for your.
Oh my God, it's unreal. I mean, for free, you can get all this coordination.
But
Low
they
P.
said the 2014 is on PDF now.
Everything is PDF. I have the NEC Code book. Oh yeah, you can. I get
So
2011.
You purchased that PDF in 2014.
Well, I think, help me here. I think they're going, every time you buy a book, they'll give you a PDF free. I think that's what they did in 2011. If you guys, I got my PDF free of charge. They have a little sticker. Here's that yellow sticker.
Yeah.
Did you guys see it?
Yeah.
Did anybody ever paid attention to it or just throw it?
No,
You got it. You got a free copy, and I believe in 2014 they're going to do the same thing. They'll give you, every time you buy it, make sure it has a little sticker here, or you don't buy the book. It gets you a free download PDF. You lose it, you call them. I did, because we got new laptop. I called them, and they got me a new. They give you access.
I used to do that all the time. Now I subscribe to that NEC Plus.
That's another thing.
Yeah.
The only thing, it's a little bit different version. It's it's not.
Yeah.
The formatting isn't quite the same, but it's pretty.
You know, the challenge with the NFP Plus is if you're not in a place where you have access to the internet, you can't get it. Here's what you get from them. Here's my NEC Code book. That's the version, and they get it to you, licensed directly to you. I don't know if you can see here. Oops, no, that's not what I want. This is not, licensed by agreement to individual. I think, I don't know if my name is here, Dunwoody College of Technology. So licensed to you directly. And
I
without
used to purchase those, but now I don't.
without this, we can't teach coding classes. We can. I don't know how people teach it without that. I don't.
Now, with all the restrictions they put on for using that,
Yeah.
I'm surprised they don't want you to load it on their network.
What restrictions? Do you want to see my network here? Now this is, let me tell you, here's my network. All these stuff, including it's going to be my channel, and I've never had any issues with it. So here's my YouTube channel, not this one. Okay, here's Chad Curdy. So everything, including this presentation, will be tonight at YouTube. So speaking of which, I have to stop recording here. Okay, here you go. So we save it. We